So for G4G in 2020, I was going to tell you about this new fiber arts result that I had, but now the result is not so new to me, so I decided to slightly pivot my talk to give a more general result about just using mathematics more generally to inform fiber arts. So the whole idea of mathematical fiber arts is to make a deep and precise connection between a specific fiber art and a specific idea in mathematics. So for example, you choose a specific fiber art like embroidery or knitting or quilting or weaving or whatever, and then connect it to a specific mathematical idea like for something from geometry or number theory or algebra or combinatorics. And sometimes the goal is to make an object that will visually display a mathematical idea, but sometimes the goal is to use mathematics to solve a fiber arts problem. And it's really most fun when these things work together, as you will see. So I'm just going to give you an example to give you the idea. And when I give you this example, it's the example that I had from my previous talk. So you're going to understand the theorem that I came to. So my problem was to explore this idea of Itajime Shibori that I had recently learned about. And so I really was not an expert in dyeing at all. So without much background experience, I decided to embark on this really big dyeing project so that I could learn about Itajime Shibori. And the way that this works is you fold your fabric and then you clamp it and then you dye it. And you're not doing dye painting, you're not doing sewing. There are other kinds of shibori that work differently, but the way that this works is you fold first, then you clamp, as you can see, and then you dye. And so it was really important to set out the physical constraints of this first, because once you set out the physical constraints, then they can be translated into mathematical constraints. And then I set out this artistic goal, which was to make all 17 wallpaper patterns using this technique. And so the second part of this that you should be getting from this slide is that it's important to set out like a mathematical/artistic goal. And so if you want to see the full comm talk on this topic, you can see it there. Or you can just, Google, and then you'll find it. So some of the wallpaper types weren't that hard to make. Like, you can just fold your handkerchief into a rectangle and then clamp it and dye it. So that'll give you star 2222 and so forth. So these 5 weren't that hard. But then a couple more were really hard to make, but then it turned out you could make them anyway. So the one on the right here, you can get by folding your handkerchief into a Mobius band, and then you can dye it. And I like to call it the monster because I think it looks like monsters. The one on the left, I actually did not think you could make. This was and also I don't even think it looks good at all. Like, I hardly think it looks like a wallpaper pattern. If you're like, yeah, that's totally bogus, I'm with you. But anyways, you get there by folding a torus, and I totally didn't think this was even possible. Sabeta Matsumoto had to show me how to do it. Thank you very much, Sabeta. But then, if you're counting, that was only 7. So where are the other 10? Because there are 17 wallpaper patterns. So for that, what happened was at some point I was so stymied by this process, I was like, what is actually going on? Am I just being really stupid? Which, as we all know, is like the process of mathematics. So anyway, I was thinking, and I was like, this kind of reminds me of orbifolds or something. But I didn't know that much about orbifolds, so I went back to The Symmetries of Things, which we all know is a great book by Conway, Burgiel, and Goodman Strauss. And so I read more about orbifolds, and I realized that I was folding orbifolds. And if you think about what you're doing, so this is why it was so important to have set forth the physical constraints, because I couldn't cut my fabric. And because I couldn't cut my fabric, I couldn't make any of the orbifolds that required cuts. And furthermore, I had to be folding my fabric in 3-dimensional space. So I couldn't make the Klein bottle or anything like that. So I could only make 7 of the 17 plain orbifolds, which is the theorem of this talk. Okay, so with Itajime Shibori, you can only make 7 of the 17 wallpaper patterns. So in other words, what I'm trying to tell you is the process of mathematical fiber arts works by carefully defining your physical and artistic constraints, setting out an artistic/mathematical challenge for yourself, and then like doing a whole bunch of stuff. Like the physical process helps you realize what's going on mathematically, or it makes you realize somehow there's this magic part where you're like, oh my gosh, something's happening mathematically, and somehow you realize what that mathematical piece is, then you go learn about it and relate it to the fiber art. And so I wanted to just invite you to engage in this really, really fun thing. And there's a venue where you can publish. It's going to be coming up. There's a special issue of the Journal of Mathematical Arts that's going to be about fiber arts. It's scheduled to appear in 2023, and complete manuscripts are due on August 1st of this year. Thank you very much.